bucka. Haha. You know the deal.
Today we're going to be talking about calculating the volume of prisms. We've talked about this a little bit already in our introduction to volume, and of course when we're talking about volume we're talking about the size of a three-dimensional shape. So here I've got a couple of three-dimensional shapes. The first one here we have, of course, is a cube, and it's a cube that's 1 centimeter by 1 centimeter by 1 centimeter. So the volume of that cube is 1 centimeter cubed. And to the right here we have a rectangular prism, and that rectangular prism has a length, a width, and a height of 4 centimeters, 2 centimeters, and 3 centimeters. So when we're being asked for the volume of this rectangular prism, well, first thing we want to ask ourselves is, well, what's the unit going to be? Since we're being asked for volume, we're being asked for the size of a three-dimensional shape, so it's always going to be in units to the power of 3. So in this case, it's going to be in centimeters cubed. So the question we're really asking is, how many centimeters cubed are in this rectangular prism? In other words, how many of these cubes will fit inside of this box? Well, in order to do that, let's think about, first of all, how many will fit on the bottom. So if we were trying to fill this box with those cubes, we would take a look at how many we could fit across the width here. And since the width is 2 centimeters, we can see that we could fit 2 of those cubes across the width. So then we ask ourselves, well, how many could we fit across the length? And since the length is 4 centimeters, that means we could fit 4 of those cubes across the length. We can see that on the bottom, the first layer that we would have there, we can fit 8 of them. And again, going back to the introduction to volume, really what that 8 represents is the area of the bottom. On the bottom of this rectangular prism, of course, we have a rectangle. The length and the width of the rectangle are 4 centimeters and 2 centimeters. So the area of that rectangle is 8 centimeters squared. So whenever we're calculating the volume of a prism, we always start by calculating the area of the base. And I'll just write this as A with a little b. That means area of the base there. And in this case, the base is a rectangle. So to calculate the area of a rectangle, of course, it's length times width. And our length and our width here are 4 and 2. So we would multiply 4 times 2. So our total area of the bottom there is 8 centimeters squared. And when we talked about area and what that means, well, that means that we could have 8 square centimeters on the bottom. Well, one of these cubes will fit on 1 centimeter squared. So if we have 8 centimeters squared, that means, of course, we can fit 8 of those cubes along the bottom. Well, we're not quite done here, of course, because we haven't really filled this box yet with these cubes. We've filled the bottom layer with the cubes, but we need to completely fill the box with the cubes. And if we continue to try to fill up this box with cubes, of course, we're going to end up with 3 layers. So we continue to fill and fill, and we can see here that if we do that, those cubes are going to kind of fill up the box in this way. So we know that we have 8 cubes on the bottom layer there. That's the area of our base. And then we have 3 layers of cubes. Well, each one of those layers has 8 cubes in it. So to calculate the total volume here, to get how many of those centimeters cubed will fit in that box, we take the area of the base, the 8, and we times it by how many layers there are. In this case, it'll be 3 because the height is 3 centimeters. And our total volume is 24 centimeters cubed. Because again, that's how many of those 1 by 1 by 1 centimeter cubes will fit inside this box. So our overall equation to calculate really the volume of any prism, we start with the area of the base. In this case, the base is a rectangle, and we multiply that by the height. So again, if we were going to do this for this rectangular prism, the base is a rectangle. To calculate the area of a rectangle, we multiply length times width. And then we're going to take that answer and multiply it by the height. So another equation for the volume of a rectangular prism is length times width times height. That works as well because length times width calculates the area of the base, and then we're always calculating the area of the base and timesing it by the height. And if we substitute our values in here, the length is 4, the width is 2, and the height is 3. And 4 times 2 times 3, of course, is 24. Since we're calculating volume here, volume will always be in units to the power of 3, so it's 24 centimeters cubed. So let's try another rectangular prism. Here I've drawn one that, in this case now we're looking at a rectangular prism where the length, the width, and the height are in meters. If we're asked to calculate the volume, we are being asked to measure the size of a three-dimensional shape, so it will always be in units to the power of 3. So we can go ahead and just use our equation that we've developed with the last example, and for any prism, it's always area of the base times the height. Because the area of the base will tell us how many squares are on the base. And if we know how many squares are on the base, we know how many cubes are on the base. And then we times it by the height because that's how many layers of cubes. So if we look at what's on the bottom here, we have a rectangle. And to calculate the area of a rectangle, of course, it's length times width. Well, that's our area of the base part of this equation. And of course, the rest of the equation is timesing it by the height. So we have to take that area of the base and times it by the height. Well, if we go ahead and substitute in our values here, our length is 5 meters, so we can go ahead and put in 5. I usually don't mind if the units aren't included in your work, but you do have to include your unit in your final answer. Our width here is 4 meters, so we're going to multiply that 5 times 4. That'll give us the area of the base. And our height here is also 4 meters, so we're going to multiply the answer to that times 4. Well, when we go ahead and start to solve that, 5 times 4 is 20. 20 times 4 is 80. So 80 is our final answer. Now, of course, we do want to include the unit in our final answer. And you'll notice here that our linear unit is in meters. So that means our unit for volume always has to be in units to the power of 3. So in this case, meters to the power of 3, or meters cubed. So our final answer here for volume of this rectangular prism is 80 meters cubed. So the next shape we're going to take a look at calculating the volume of. Now, this of course is not a rectangular prism. This is called a triangular prism. Now, just like with all prisms, we calculate the volume by multiplying the area of the base times the height. Now, if we take a look at this prism here, if I were going to, say, use this shape as the base here, so the rectangle that's on the bottom, if I went to put cubes there, well, I could put 4 cubes across this side without any problems at all. But when I go to put cubes across this side here, what ends up happening is some of them actually get cut off. Because of the angle of this side here, I can't put whole cubes along this edge. So when we're using our equation area of the base times the height, I can't really look at the shape like this, because if I look at the shape like this, if I try to multiply the area of the base times the height, it's not going to work here, because those cubes, of course, will be cut off. If I were to, say, put 2 cubes across the bottom here, well, already one of them is being cut in half, it looks like. Or at the very least, it's a fraction of a cube. We can see that here. We don't have a whole cube there. I can definitely put 4 cubes across this side without any difficulties at all. But again, the cubes that we have here, they're going to get cut off. So I can't multiply the area of the base times the height unless I change the way that this shape looks. So what I've done here is I've taken the exact same triangular prism, but I've turned it. So I've taken what we have here and kind of turned it so now the triangle is on the bottom. Well, now if I go to calculate the area of the base, that'll tell me how many squares are on the base. And if I know how many squares are on the base, I know how many cubes I can fit on the base. Now, in this case, some of them will still be cut off, but I can stack them one on top of the other because they'll be stacked in exactly the same way. So even though we only have part of a cube here and parts of cubes here and here, of course, those parts will be stacked in exactly the same way from the bottom all the way up to the top. If we look at the top of the triangular prism now, if I were to stack them along the top, it's going to stack in exactly the same way. Something along the lines of that. So even though they are cut off, they're cut off in the same way all the way through. So we can still use that equation, volume is area of the base times the height. But now, the thing is the base has to be the triangle. We have to consider the fact that when the shape is looking like this, we can't use that rectangle as the base because those cubes will get cut off as they go up. They'll get smaller and smaller as they get up. What we have on the bottom here, well, will not be the same as what we have at the top. At the top here, we just actually have a line. We don't even have a shape at the top here. But when we look at the triangular prism in this way, well, what do we have on the bottom? We have a triangle. And what do we have on the top? We have exactly the same triangle. So if we're going to stack the cubes on top of each other, they're going to stack in the same way all the way through this shape from the bottom to the top. So we can use the equation area of the base times the height, but the triangle has to be on the bottom. So when you're faced with a question like this from your textbook or on a quiz or a test, sometimes it's actually helpful to redraw the triangular prism so that the triangle is on the bottom. Or at the very least, you have to imagine, well, if I turn this triangular prism so that the triangle is on the bottom, that means that this 4 centimeters is the height. So how do we calculate the area of a triangle? Well, the area of a triangle is base times height divided by 2. Now, here's where this equation can get a little bit confusing because the height that we're talking about here is the height of the triangle. The height that we're talking about here is the height of the triangular prism. So if I'm going to substitute in the values into this equation, well, for area of a triangle, I'm looking at the triangle here on the bottom. And the base is 3, the height is 2, because it's a right angle triangle. So we multiply 3 times 2, and of course, base times height divided by 2. The height that we have here is the height of the triangular prism, which is the 4 centimeters here. So again, we can use the equation area of the base times the height. Go ahead and calculate the area of the base. 3 times 2 divided by 2 is 3. So that's the area of that triangle, 3 centimeters squared, times the height of the triangular prism, so times 4. So the total volume here is 12. And of course, again, we're talking about volume, so we're talking about the size of a 3-dimensional shape. So it'll always be in units to the power of 3. So to finish off our lesson today, what I'm going to ask you to do is calculate the volume of these 4 prisms. If you get stuck and you're not sure, take a look back at the video to see how we calculated the volume of each of these shapes previously.